¿Cómo estás, my friends? Hello, we are in Spiral 1. So what we're going to be doing for the next few days is just talk about some things that we should review, make sure that we know, and according to our little questions over the past few weeks, these are things that we need to talk about, okay? So we're going to be reviewing irrational and rational numbers today, so this is going to be a little calculator heavy. And to be reminded, rational number can be written in the form a over b. A and b are both integers, aka 2. So remember, 2, any whole number is actually over 1. So we have 2, 5/8, 2.75. So those repeating decimals, okay? Ones that make those really pretty numbers in your calculator, as opposed to irrational numbers where they cannot be written in the form a over b, when a over b are also integers, okay? So radical 2, radical 10, pi. Those things can't be written as a fraction when you put them into your calculator. So all we're going to do is label each of these things as rational or irrational. I'm going to use R for rational and I for irrational, and I'm just going to plug these into my calculator, okay? So I'm going to start with radical 9. I'm going to go down this little list. So remember, to put a radical in, you hit your second button and your x squared button. So there's my radical, and I want to do radical 9, which gives me 3, which is a pretty whole number integer. So that means that this is a rational number. Okay, let's look at 3 radical 2. Okay, well, it's non-repeating, non-terminating, but let me see if I can write it as a fraction. So I'm going to hit math, and notice how it says the 1 is lit up, so it says frac, and it says, do you want me to turn this answer into a fraction? And I say yes, and it does not turn it into a fraction, so therefore it is irrational. So this cannot be written as a fraction, okay? So what about 3 minus radical 5? Okay, non-terminating, non-repeating. Can I write it as a fraction? No, so irrational. What about 2 pi? So the pi is right over your little caret, and it's in blue, so I have to hit the blue button first. 2 pi. Okay, so here we go. Math, enter, enter. Cannot be written as a fraction. Irrational. Okay, all right, so what about radical 2? Okay, notice here I have a radical. If I just keep typing, it's going to type inside my radical. Okay, I don't want that. So I want radical 2. I'm going to arrow out and do times radical 18. Oh, well, that gives me a nice, pretty 6. So this is rational. All right, so what do I have here? I have a fraction. So first thing I'm going to do is put the fraction. I'm going to hit alpha x. On the top, I have radical 10. At the bottom, I'm over 2. Okay, non-repeating, non-terminating. Let's see if I can turn it into a fraction. I cannot. Irrational. Okay, what about 3 plus radical 25? 8. This is rational. All right, let's look over here. 2 and 2/3. Well, what is 2/3 as a decimal? It's 0.666666666. Okay, can I write that as a fraction? Absolutely. So this can be written as a fraction, and all you're doing is just adding 2 to it. So this is rational. Okay, what about radical 24? Non-repeating, non-terminating. Can I write it as a fraction? No. Irrational. All right, 16 minus radical 16. Pretty, 12, rational. All right, 5 radical 20, non-repeating, non-terminating. Can I write it as a fraction? No, irrational. 5 radical 100, 50, pretty number, rational. All right, negative radical 60, arrow out, plus 2 radical 15. Oh, this gives me a 0. 0 is still just an integer, so this is rational. And what about 4 minus radical 5? All right, non-repeating, non-terminating. Can I write it as a fraction? No. Irrational. Okay, so Perfect. We've seen the difference now. Now we're going to do the rest of these. 1 through 6 are all Regents questions that pertain to this topic, okay? So number 1 says, state whether the product of radical 3 and radical 9 is rational or irrational. Explain your answer, okay? What does product mean again? Okay, product. This means to multiply. So you're going to have radical 3 times radical 9. All right. Well, let's put that in our calculator here. So I get radical 3, arrow out, times radical 9. All right. Let's see what that gives us. This gives us something that's non-repeating, non-terminating. Let's see if I can turn it into a fraction. I cannot. So is irrational. Okay. This is irrational because cannot be written as a fraction. Okay, oopsies, got a little twist on you. So this is irrational because this actually can't be written as the ratio of 2 integers, okay, or aka a fraction. So let's see, is the product of 2 irrational numbers always irrational? Okay, well, we have to think about this, okay? So is the product of 2 irrational numbers always irrational? I think we saw an example like this already. So what we're going to do is try to provide examples and counterexamples, okay? So an example would be 2 rational numbers being irrational, and then a counterexample would be 2 irrational numbers being rational, okay? So all you have to do here is just pick some numbers and multiply them together. So I'm going to do radical 2 times radical 18. Okay, so first let's check that they're both irrational. So radical 2, irrational. Math, fraction, okay. So this is irrational. Radical 18, math, nope, irrational. Okay, so what do I have here? I have the product of an irrational times an irrational. If I multiply these two together, radical 2 times radical 18, my answer is 6. Okay, so is the product of 2 irrational numbers always irrational? The product of 2 irrational numbers is not always irrational because we'll just say radical 2 times radical 18 equals 6. Okay, so we just provided a counterexample that said, no, it doesn't always work because I can show you that it works. It gives us a rational number. Okay, and then this is going to be the last of it today. So 1, 2, 3, 4 more questions, and they are all calculator questions already. So this one I think was even on one of the tests that we gave. Given radical 2 is L, M is 3 radical 3, N is radical 16, and P is radical 9, which expression results in a rational number? Okay, so I'm looking for those can be a fraction or those pretty numbers, okay? So the first one says L plus M. Okay, so remember what L is. L is radical 2. M is 3 radical 3. So now all I do is put this in my calculator. So I have radical 2 plus 3 radical 3. Okay, well that gives me an irrational-ish number. So math, fraction. Okay, so this is irrational. All right, let's do M plus N. M is 3 radical 3. N is radical 16. So I get 3 radical 3 arrow out, plus radical 16. Non-repeating, non-terminating, can I turn it into a fraction? The answer to that is no. So this is also irrational. Okay, what about n plus p? So n is radical 16 and p is radical 9. Okay, radical 16 plus radical 9. Oh, this equals 7. This is rational. Okay, so this is my rational number, nice and pretty. So p radical 9 plus l, which is radical 2, just to check. So this is irrational as well. Alrighty, that's the gist with all of these, okay? So you're just checking if sums, products, or whatever are rational or irrational. So given the following expression, I have 1, 2, 3, and 4. Which expressions result in an irrational number? Okay, well, let's just put these into our calculator and see what we get, okay? So I have negative alpha x, because I want a fraction, 5 over 8, plus another fraction, 3 over 5. Okay, well, this is negative 140. Okay, is this written as a fraction? Well, then this is rational. Okay, what about alpha x for 1/2 plus radical 2? Oh, okay, so I have non-repeating, non-terminating stuff going on here. So math, enter, enter. Cannot write it as a fraction, so this is irrational. Alrighty, let's check the other two. Okay, so I get parenthesis radical 5, close the parenthesis, times parenthesis radical 5, close the parenthesis. Okay, well, this tells me that I just get a normal number 5, which is rational. Okay, and then, oopsies, we lost our bracket here. And then this last one says 3 times parenthesis radical 49, close parenthesis, and this gives me 21, which is also rational. Okay, so the answer says which expression results in an irrational number? Well, this one was the only one that gave me an irrational number, so number 1, 2 only. All right, same idea here. For which value of p and w is p plus w a rational number? Okay, well, p plus w, so I'm looking at 1 over radical 3 plus 1 over radical 6. All right, well, what does that give me? Fraction 1 over radical 3, arrow out, plus fraction 1 over radical 6 gives me non-repeating, non-terminating. Okay, math, enter, enter, cannot be written as a fraction. So this is irrational. Okay, I'm looking for rational, so this one isn't going to work. Not that one. Okay, so 1 over radical 4 plus 1 over radical 9 equals, all right, put it in here. 1 over radical 4, arrow out, plus 1 over radical 9. Oh, 5, 6. Well, this is a fraction, right? Written as a fraction. This is rational. Cool. So number 2, it is. Alrighty. So last one says which expression results in a rational number? I'm looking for rational again. Okay. So let's do radical 2 times, oopsies, that's a minus button, times radical 18. Oh, that's rational. I guess we can check. I don't know. I hate when it's the first choice. 5, radical 5. This is irrational. Okay, oopsies. Radical 2 plus radical 2. This is irrational. And then 3 radical 2 plus 2 radical 3. This is irrational. So it was the first choice. I just like to double check. Alrighty, that's all. Have a wonderful day.